Assalamualaikum warahmatullahi wabarakatuh. We are from group 9 from section 3 and we will present about the application of first order and second order linear differential equation. So my name is HAKIM bin Muhammad ZULKIFLY and these are the name and metric number of my group member.
Assalamualaikum warahmatullahi wabarakatuh. My name is ALIFF ANUAR bin AZMI. My metric number CD221042. I'm from Group 9, Section 3. Today I will present about application of first order and second order. Okay, for the introduction of first order, second order, differential equation can be used to represent the size of population and varies over time. In this topic, we study logistic differential equation and see how we apply to the study of growth and decay in the context of differential equation. In order to use a differential equation to simulate the growth and decay, the first step is to define some variable and relevant terms.
Assalamualaikum, my name is NILAMSARI HALIM and my metric number is CD210171. So for today, I will present about the variable involved. So the population growth is dx over dt equal to kx and the simple general solution consists C equal to initial value and k equal to constant of proportionality and t equal to time. If k is bigger than 0, then it is a growth model which always increases. Next, the direction of equation. This law of population growth is called Multichain Law. C is a constant of integration. Then C and K are determined with the help of initial condition, where xt equal to C exponent of power of K. Therefore, C is the initial value and can be found from the initial condition. Yt0 equal to y0. K is the constant of proportionality. Lastly, the method of solution. It is the separable equation method that can be used in this case to obtain the general solution of the equation. The general form of first order ordinary differential equation is dy over dx equal to fxy. In some cases, fxy can be written also as fxy equal to ux vy. Therefore, dy over dx equal to ux vy. By separating the equation as dy over dx equal to ux vy, so we will get the dy over vy equal to ux dx. We get the separable equation by integrating both sides. So the solution can be found.
Assalamualaikum warahmatullahi wabarakatuh. My name is SHAKILLA binti HUSSIN and my matrix number is CD210134 and I'll be presenting about sample calculation for population growth. The equation stated that we need to find the time required for the culture to increase 10 times from its original size. And first, we need to let Pt be the size of the culture after t days. This equation tells us that the population grows at a rate that is proportional to the size of the population, and the population growth rate is dp over dt. Next, we can find the constant value by using the additional condition, and by using the additional condition from the equation, we can find the value of k, which is equal to 0.173. And lastly, we can find the time required to increase the size 10 times from its original size by putting the k value into the equation, and we got the final answer for this equation is equal to 13.3 days. We got that the longer the time taken, the more bacteria reproduce. That's how fast the population grown at a given rate.
Let's move to the second order differential equation. Okay, we solve particular case that demand the various method of calculation. Basically, for the second order differential equation, discuss superposition and derive the characteristic polynomial to create general solution. Second order has a homogeneous equation and non-homogeneous equation. The main issue is to know how to identify the equation and what the strategy to employ. So it may be easy to solve the problem and define the answer for the general solution.
Assalamualaikum, I'm FAREEZ SHARIP and I am going to present about the second order differential equations. Now I am going to start about the variables involved. In this second homogeneous equation, it is related to the Newton's second law of motion, which is F equals to ma. Then we derive it using the second derivative displacement u for the acceleration, and we will get new equation, which is F times T U prime equals to mu double prime. There are four forces that will or will not act on the object, which are first, spring force, second, damping force, third, gravity force, and last is the external force. Next one is the derivation of equation. We will derive the Newton's second law by applying all the forces that have been said before and get new equation. So it is mu double prime equals to mg minus k times L plus u minus c dx times dt plus ft, and the final equation after derivation is mu double prime plus cu prime plus ku equals to ft. And lastly is the method of solution. In these types of damping, we might get different types of damping depending on the roots we get. If we get two real roots, it means that it is a over damping. If we get a real double root, the damping is known as critical damping. And if we get complex conjugate roots, the types of damping is under damping.
Assalamualaikum warahmatullahi wabarakatuh. My name is SHAKILLA SABRI. My metric number is DB200180. So I will present the sample calculation for second order homogeneous. So I got the question here, and then I convert it to the differential equation formula, which is a y double prime plus 8y prime plus 16y equal to 8 sin 40. So we do the quadratic formula that r power of 2 plus 8r plus 16 equal to 0, and then we got the two equal root. And then we put it to the general solution, which is yc equal to c1 e negative 4t plus c1 t e negative 4t. So we need to find the yp. Yp we got from gx sin 40, and then we convert it to yp a sin 40, and then we differentiate yp prime equal to 4 a sin cos 40, and then we differentiate it again, we got negative 16 sin 40. And then after we do the calculation, we got the negative 1 over 4 cos 40, and then we put it together, y equal xt equal to yc plus yp, and then that the answer we got. And then the transition solution is 1 over 2 exponent negative 40 plus te negative 4t. So the steady state solution is negative 1 over 4 cos 40. So for discussion, we got the answer, and then we conclude it to the this solution. We got the over damping because the root is equal.
My name is HAKIM bin Muhammad ZULKIFLY, metric number CD210051. I will present about the conclusion of this assignment. So, as conclusion, many engineering applications need the differential equation to ease people solve the problem. The first order differential equation for part A is used to analyze the growth of the population related to Multichain Law, the derivation of equation by using the separable method. The important things about the differential equation are how to identify the method that related to the application and reach the objective. Mechanical vibration may be an examination by utilizing moment range differential condition. There are a few sorts of examination for mechanical vibration, such as free vibration investigation by straightforward mass spring framework. So that's all from us. Thank you.